So every ZK proof ever built, they all run on one primitive, and that's commitment scheme. So if you understand how commitment schemes work, then you understand how ZK is even possible. So let's see the problem that ZK has to solve. So you know a secret, it can be a password to a safe or whatever, and you want to prove that you know this without showing it. This obviously creates some sort of paradox, right? If you show the secret, the verifier believes you, but now they know your secret. That's not zero knowledge because you leaked everything. And if you show nothing, your secret is safe, but the verifier has no reason to believe you because you have not proved anything. You have not proved anything, right? So zero knowledge needs something in between. You need to show enough to convince, but not enough to make. So commitment scheme are the in between. So big question though, what is a commitment scheme? So commitment scheme is a way to lock in your answer now and prove it later without revealing it in between. And at its core, it's this formula. So C for commitment, that's what you hand over to the verifier. M is the secret value, and R is the random number you mix in. And that random number is the key to absolutely everything. So let's understand this in its two key phases, right? There is the commit phase and there is the reveal phase. Okay. So in the commit phase, you take your secret value, mix in some randomness, and produce the commitment, which is now a scrambled value that represent your secret. And that's what you hand over to the verifier, and they're holding your answer, but they can't see what it is. All right. In the reveal phase, you hand over the original secret value and the randomness, and the verifier plugs both into the same commit function and checks if the result match the commitment you give them or you gave the verifier earlier. And if it does, that means you didn't change the answer and all that stuff. So all this produces two key properties: hiding and binding. Fun, right? Yeah. So hiding means looking at the commitment tells me or tells you nothing about the secret value. So if you look at that commitment, it will tell you absolutely nothing about the secret value. And binding means once I hand over the commitment, I cannot swap the secret value with something different. It's locked in and that's it. So here's why this matters for ZK, right? So without commitments, a cheater sees the verifier's challenge first and they can work backwards and fake a correct looking answer without knowing the secret. So this is like getting exam questions before the exam. So commitment sort of like kills this cheat. So the prover locks in the answer before the challenge arrives. Okay, so the prover commits first, then the verifier challenges, then the prover opens only what was asked. Okay, so this is how commitment schemes actually make ZK work. Binding gives you soundness, so the cheater committed to garbage before seeing the challenge. Now the challenge arrives and their garbage doesn't match, obviously. So they need to change their answer, but binding doesn't let them. That's it. And that's how they're caught. Hiding gives you zero knowledge. So the honest prover only opens the commitments the challenge asked about, and everything else is sealed. And because of hiding, those sealed commitments looks like random noise. The verifier learns the answer checkout and nothing else. Right? And that's it. Binding catches cheaters and hiding protects secrets. And that's how commitment schemes makes ZK possible. So every ZK system, snags, stacks, and all of it is just a more sophisticated version of the same dance. And now you know if you didn't.